Hey pilots, DrainMan here, and today I have got a very special video. In today's video, we are going to build a DIY power supply. This is the ultimate power supply. If you're any type of drone pilot, hobbyist, electronics enthusiast, if you get involved with electronics at all, and that means drones too, then this is something you definitely need to have in your arsenal. Alright, pod, so the first thing I want to do is I want to showcase it to you. I want to show you what this is and what it has to offer. Now, right up here is 3 switches. These switches all control a different color. So we have blue, we have red, and we have green. So if that's what you're into, man, run your color. Now, what if you want yellow? Well, this doesn't have yellow. Well, guess what? Yes, it does. You put a little bit of green and a little bit of red, and now you've got yellow. Well, what if you like purple? Okay, red and blue. Now you've got purple. This thing is awesome. All right, and that's just part of the fun because that's what I did there. But let's go ahead and show you guys what it looks like. I'm going to power it down. There you go. Now it's off, ready to go. You'll see that I used some 3D printing to trim it out. We've got a PC fan, and then the back and the fronts are 3D printed. And I went ahead and I spray painted some wood. Nothing special. That is the sides and the top and the bottom. It's really not that difficult, and my choice of what I use to make this as a case, you can use whatever you want. I have a 3D printer, so I decided to 3D print it. You do not have to use a 3D printer. If you don't have one, get some wood, get some plexiglass, and you can go ahead and make the same exact thing with just different materials. In this video, I'm going to show you how I made this one exactly, so that way if you're interested in my exact design, you can use it. Down in the video description, you will find timestamps so that way you can navigate through this video. You will also find links to all of the things that I used, including the components. And at the end of the video, I will show you some of the useful things that this power supply can do. If you're a drone pilot and you don't have one and you don't know why you should have one, you're going to want to go ahead and check that out. So the very first thing we need to do is we need to get our case design together. If you want to just use some wood like me, I went ahead and I cut 2 pieces of 6x8, and then I went and cut 2 more pieces of 8x8. That is going to be the 2 sides and the top and bottom that we're going to need. I did cut 4 pieces because I was going to do the whole thing in wood, but I decided later that I thought it would be cool to have some plexiglass or 3D print on the front and back. That way the LEDs can shine through much easier. Next up, we need to give the wood a little bit of basis, so I went ahead and I hit it all with a clear coat. The wood that I decided to use is an MDF board. This is a medium density fiber board. You are welcome to use any type of board that you want. I chose this stuff. It's extremely affordable and it works well with all types of applications. Give your clear coat plenty of time to dry. Once it's dry, you want to go ahead and hit it with some sandpaper. If you don't have a plug-in sander, feel free to just use your hand and some sandpaper and give it a good sanding so that way your edges and corners feel really nice. The next thing we need to do is we need to prime our wood before we go ahead and give it our nice coat of paint. You can use any type of primer you want. I didn't want to waste time with a paintbrush, so I bought the spray type. This is made by Rust-oleum and it's called Zinsser Bullseye 123 Plus Spray Primer. I got it in white, but you're welcome to do any color scheme you would like. Make sure you give it a nice even coat, let it dry, and if you see any spotting or if you see any blotching, be sure to sand it down and then hit it with another coat. So for me, this is one of my favoriteest parts of this entire build, and that's having fun spray painting my case with any cool design that I want. I'm no professional by any means, and I kind of really have no idea what I'm doing with paint, but I had a lot of fun. I spray painted it. I think you're going to absolutely love the way that this came out, and you're more than welcome to use the same idea that I did. And what I did first is I got myself a real cool scattered background with all the different colors that I wanted to incorporate. After I did that, I went ahead and chose my accent color. I wanted to use white, and I made a big blotch of it, and then I used crinkle paper and my pinky and rolled it over it to get this cool effect that you see right here. Then take any shape or size, whether it's a circle, a star, a square, doesn't matter, use any shape you want and lay it on top of it. Once you do that, then you can spray paint around it again using the colors that you want to pull out of it, so that way when you lift it off, you finally have your final design with the cool crinkled background look. If you want to pop it out even more, you can use a little piece of cut paper or cardboard, and you can splash on little stars and little corners and little arrays of different colors to really make your cool design pop. And with a little bit of love from the paint gods and a little bit of luck, you might have something that looks halfway decent. Mine came out pretty good. I'm actually really happy with it, and I can't wait to continue the build. Now it's time for electronics. Alright, let's go ahead and check out our AC to DC converter. When we plug in our power supply to the wall, we're going to be plugging into AC voltage. We really need DC voltage to run our power supply because most of our electronics run on DC current. So what I've got here is an AC to DC converter. This one allows 36 volts at 5 amps. We don't have to use it all, but if we are going to use a full 5 amps, for a long time, we're going to need some type of heat dissipation or some type of cooling. There is a little heat sink built in, as you can see, but we're going to install a PC fan to help keep it really cool, so that way if we push this guy hard, we won't have any issues. For right now, don't worry about your live and neutral, just connect them in any way that you want, and we'll deal with that later. Now, because it doesn't have a switch, I'm going to use a power strip that does have a switch. That way we can control it. I'll set my multimeter to AC testing, and then I'll go ahead and I'll test the AC. As you can see, we're getting 120 volts. The next thing I'll do is I'll test the output. This is supposed to be putting out 36 volts. And as you can see here, we're putting out 35.9. So let's go ahead and take a look at our variable bench power supply unit. This is a buck boost converter that does pretty much whatever we want it to do. It can handle anywhere from 6 to 55 volts. It has a 1.44 inch colorful LCD monitor display. It can show voltage, input voltage, output voltage, and preset current. It also shows the output current. It has up to 10 memory options, and it has the 5 amp output to match the supply. Next up, we're going to go ahead and design our front and back panels. We're going to need to design this inside of a CAD software. This is Fusion 360. It is a 3D CAD software that you can get online. If you do not have a 3D printer, you can use plexiglass and a ruler and go ahead and make yourself something very similar. For me, I've used LEDs, so I made sure that I printed it with clear filament. If you're not going to use LEDs, then you can just go ahead and design yours out of wood. I'm going to go ahead and link this panel down in the video description so you can find this file and you can pull all the measurements if you decide to build this on your own out of something other than a 3D printer. If you do have a 3D printer, well, go ahead and download this file and go ahead and print it in any color that you would like. Yeehaw! Now it's time to start putting our components on our front panel. That includes installing the module, the power supply module, also our dual USB, which allows us to plug two things in at one time. After that, we're going to get all of our banana connectors in. The banana connectors are very important. This is what allows you to plug in all of your everyday stuff. Any type of clamps, clips, alligator clips. You even have screw posts where you can just put bare wire to anything you want to wire up and give power to. You gotta have those. That's why I put lots and lots of them, so that way I have tons of options while I'm testing my gear. Now for our XT60 connector. You can't just wire these up while they're already installed. So I pre-soldered them, then I pulled them through their respective holes, and then I put tons of Loctite glue on them so that way they can't go anywhere when I'm pushing and pulling. So I use these little mini voltmeters, and they come with two little ears with holes for screws. Well, I'm not going to drive screws through my print, and if you're using plexiglass, you're not going to drive screws through that either. So I'm going to go ahead and just use a little bit of super glue by Loctite, and then I just plop it right in. Make sure your orientation is correct, and make sure you can still access it because we have to adjust it later. I'm going to go ahead and use my hot glue gun, and I'm going to put a little bit of hot glue around just to kind of help keep from any type of conductivity and also hold everything a little bit secure. I don't want anything falling out after I put it all together. Don't forget, down in the video description, I have links to everything you see here. Alright, so next up is our step-down converters, also known as buck converters. They come with heat sinks that have a little bit of thermal sticky tape. Make sure you stick that on your voltage regulator module, so that way when it heats up, it'll help dissipate. These can take anywhere from 4 to 38 volts on the input, to 1 1/4 to 36 volts on the output. That means you just use the little potentiometer and you turn it to the voltage that you need for your application. As you can see here, I'm going to do one for 3.3 volts, I'm going to do one for 5 volts, and I'm going to do one for 12 volts. These are your most common voltages when you're working with electronics. So I want to have those exclusively laid out on our power supply unit. Let's not forget to make one for our dual USB. It can handle anywhere from 12 to 24 volts. I decided to go at 12 volts, but wanted to give it a hair more, so I gave it 13. Next up is our CPU fan. I call it a CPU fan, but it's really just a cooling fan. You can use any little fan you want. The idea is just to make sure that you keep it cool. So I laid it on top of the box, I traced it out, and then I used my Milwaukee Dremel to cut the hole. After I cut the hole, I went ahead and used my smaller Dremel and I sanded it down a bit just to get it nice and smooth. Once I've done that, then I went ahead and checked, made sure I had it in the correct position, and then I used some hot glue and I put it in place. Now we can all admit, without the perfect size hole saw, no matter how good you are with the Dremel, it's probably not going to look good. So this was another opportunity for me to use the CAD software Fusion 360, and I modeled up a nice little cover. After I did that, I went ahead and printed it out in a cool blue color, which will match the theme of my supply. Now it's time to go ahead and put the front panel on. I used a smaller drill bit than the size of the screws, and I pre-drilled the holes, and then I put the screws in to fasten the front panel on. Alright pilots, now we are on to the very fun but very intricate part, and that is where we begin to wire everything up. I start with installing the first buck converter, and I do that with a little bit of hot glue, and then I solder on the outlet side. On every buck converter, you have an inlet and an outlet. You have your voltage coming in, then you step it down, and you have your voltage coming out. So for example, I've set this one up to be a 12 volt. So I take the positive and the negative wire and I put them to the negative and positive terminals of my banana connector that's going to be my 12 volt rail. Then I do the same thing for my 5 volt and I do the same thing for my 3.3 volt. And last but not least, I make another one for 13 volts, which I then connect to my USB connector. Additionally, I take the same negative and positive wires and I loop them back to the negative and positive of the terminal posts. And by doing that on the output side, that means that whatever voltage is coming out of my buck converters is going to be displayed on the voltmeters. And at the same time, that is the same voltage that's going to be available for me to connect to. Buck converters offer a more efficient solution with fewer, smaller external components. They are able to provide voltages stepped down with a minimal number of components while offering a lower duty cycle and higher efficiency across a wide range of input and output voltages. I use a hot glue gun because it's safe for the PC board and it's not conductive. It's also very affordable. These days you can get a hot glue gun and a bunch of glue sticks for like 12 bucks. I'll link one down in the video description for you if you don't have one. Now it's time to go ahead and wire up our power supply module. It's got an input and an output. So that's 4 posts, 2 negative, 2 positive. I'll make sure that the negative and positive on the input are coming directly from the AC-DC converter. Meanwhile, the outputs are dropping down to a board that I'm going to use to disperse all of my different voltages. There's a lot going on here and I don't want to be heat shrinking a bunch of stuff. So what I've decided to do is use a little through-hole PCB solder board, and I'm going to just break up different sections. Now on the 2 banana posts that are going to be my main connectors with variable voltages, I've stripped a long piece of wire and I just jumped them across it. Well, because it's going to be the same voltage, so why bother? So we call this soldering in parallel. By doing this, I can ensure that my voltages will be the same and they'll be accurate. We'll need to keep in mind that even though we have many different connection points and we can run many different outputs of voltage, that they all consist of the same 5 amps that we have to offer. So we can't connect a 5 amp load on the 3 volt and then try to connect another 5 amps on the 5 volt. Naturally, I want to take my positives and connect them to my positives and then take my negatives and connect them to my negatives. But we can't do that. We have to remember that we have switches on board. So I need to connect my grounds to the switch, and then on the other side of the 2-position switch, I need to bring that back to my ground. So that way, when we throw the switch, it will break the ground and disconnect our circuit. So on the outputs of all of our buck converters, you saw that we ran them independently to their destination. But on the input, we don't have to run all those wires. It's all going to be ran in parallel. So as you can see, I've taken some thicker gauge wire, both red and black, and I'm running them from one and then looping it to the next and then looping it to the next. That allows the same voltage to come through these wires and power all of our regulators all at the same time. Then once I reach the last converter, I'll connect one last negative wire and one last positive wire, and I won't connect it to anything, because the positive wire is going to loop back around and connect directly to the AC-DC converter. Meanwhile, the black wire is going to jump over and connect to the same spot that I've connected all of the other ground wires. And one wire will leave that ground connection point and head to the front side of my 2-position switch. Then I'll take the secondary pole off that switch and loop it back around and connect it to the AC-DC converter. This means that only one wire will be connected to the negative side of the AC-DC converter. So with that being said, I'm going to go ahead and jump these two together to give me the most grounding possible. And that will conclude wiring up our power supply. I'll slap a little hot glue to the bottom of the converter and put it in its place. Now that was a lot of wiring that happened really fast, so if you have any questions or concerns, please feel free to ask me in the comments. I would be happy to help. Now we're on to one of the very last steps. For me, this is one of the most exciting steps because I love the look of having the RGB LEDs inside of the power supply. I bought some basic rope LEDs. They are RGB, and I went ahead and just stuck them to the side, to the bottom, anywhere I could make them fit. I tried to get as many as I could in there. I really didn't worry too much about the heat because we have a large PC fan right here. It'll keep everything nice and cool. So my original thought was I would wire them back to potentiometers, but unfortunately, LEDs don't work well with potentiometers, so I've decided to use switches. This will allow me to add the 3 colors in any combination that I want. If you want to do that too, be sure to run the front side of the switch down to our main ground pad so that way it's connected to the circuit, and then connect your red, blue, and green to the back side of the switch independently. You don't want them all to turn on at the same time. We stripped a lot of wire and we cut a lot of wire, so I used my keyboard duster and I sprayed inside very well. Now it's time to install our back panel. I take the main AC plug that's coming from the power outlet and I fed it through the predetermined hole that we designed inside of the CAD software. I then connect my live wire to one of the 2 poles and I connect my neutral wire to the other pole. Then I take the ground wire and I solder it right where the ground symbol is. Then I drive a screw through it, and I actually take some solder and I tack weld the wire to the screw to the board so that I can get the best grounding possible. Now, before we do our first initial startup, I check everything for continuity to make sure we don't have any shorts. Now it's time for our first power up. I go ahead and I plug the power supply into the wall. Immediately the LED indicator comes on, letting me know that everything is working fine. I power up the power supply, and what do you know? It works. Our cooling fan is up and running with its super cool LEDs, keeping everything nice and cool. I see that on the power supply, my voltmeters are showing bad readings. We know that we set the voltage regulators to be at the correct voltages. We have 5 at 5, 3.3 at 3.3, and 12 at 12. What we're finding here on the voltmeters is that something is off. Well, we know it's not the regulators because we set those with a multimeter. So what we need to do now is we need to adjust the voltmeters. There's a small potentiometer on the back. What I'll use is a very small screwdriver, and I'll adjust those until everything is matching. Be sure to be very thorough on this step, as a power supply is supposed to be very accurate. If you're going to use it to power up sensitive components, you might find yourself in trouble if you try to skip this step. Now, with everything complete, all of our wiring done, all of our adjusting done, now we're ready to put the top on. Be sure to not put the top on if you haven't completed everything, because then you just have to open it again. I've got a really tight fit here, so I go ahead and bang it down a bit, and then I power it up to check everything out. Look at this power supply. Even the back looks cool. So you got no problem showcasing your new power supply because it looks really cool. Now, if you remember that ring that we printed for the fan, now it's time to put that on along with any other final touches. I use some hot glue, and then I just simply push it on. Be sure to go easy on the hot glue, and if you use too much, wait for it to cool down before you try to peel it off. Right down here, I've installed a 2-position switch, and this will allow us to power it on. So now the unit is on. When it turns on, this little guy right here, which I'll put a link for down in the video description, this powers on, but is not on. To turn this on, I would press this button here, and then it would power on, as you can see with this little screen as an indicator. Over here, we've got XT60 Male and Female, and then I've put 2 rails of banana connectors. These allow you to do so much. So anything that I run out of this power supply, meaning 10 volts, 12 volts, 30 volts, 23 volts, doesn't matter. If I need a specific voltage, or maybe I need to limit the current for some reason, I would run it through these rails right here, and these rails would protect my components, and these rails would also allow me to put any voltage that I want. So I would just simply press this set button, and then I would press the enter knob, and then I can change the voltage to anything I want. And then if you wanted to charge something, this is fully CCCV, which means constant current, constant voltage, which means that I can use these XT60s or these here, and I can charge or do whatever I wanted out of this. A LiPo battery, for example, plug her right in and charge her right up. Now, there is a little bit more to that, so don't just go doing that if you don't know what you're doing. But if you do know what you're doing, this will be great for that. Now, on this side here, I have a specific set of rails set up. I have a 330 set up, I have a 5 volt, and I have a 12 volt. Now, these are very, very common in electronics. Most things run off of one of these 3 voltages, so that makes life very, very simple. I can go ahead and set this to, let's say, 19 volts. Then I can take this connector here, I can plug it in, okay? And now I can take this and I can plug in my soldering iron, boom. And as you see, it's powering my soldering iron. So now I can turn on my soldering iron, and I can literally use this to power that. Okay, so now I can take these connectors here, and I would just take the banana plug, and let's say 5 volts. So I'll plug that into there. I'll plug that into there. And I can now take this board right here, which actually it already has an XT60 on it. I could just power it up with this. But what I can do is I can take the positive and clip it to the positive. I can take the negative and clip it to the negative. There you go. So I've now put voltage on this, and you can tell by looking at the little lights on the flight controller that this is powered up, and it's safely powered up, and it's powered up with a set voltage that I've predetermined by using which rail I want to use here. And this is just a beginning of what this thing can do. This thing has so much potential. Watch this. I will take my drone here, and before I do anything with my drone, I'm going to connect this plug, and let's go ahead and check this drone and make sure it's okay before I go plugging up. You'll never need a smoke stopper again. Before I go doing anything crazy, let's go ahead and power this guy up. Come on, man. Now, I can go on and on for days showing you everything that this thing can do. Also, if you have a set of alligator clips and a pair of wires, these plugs also allow you to untwist them. We could clip in this, lock it down. We'll tear a little bit of that. That's wired up, and what I'll do is I can take these clips. You'll see that I'm putting out 330. Also set up dual USB, so you're going to see that I'm going to plug this in. Boom. Now watch this. I'm going to take my phone and I am going to plug it in. I am now charging my phone right off my power supply. So I'm going to let that charge. And it is a dual USB, so I could connect another one. And not to show off or anything, but I'm going to go ahead and light this place up while I do all my testing, because this thing is sick. Alright, pilots, I think that I've showed off enough. I think you guys get the idea of how awesome this is and how badly you need one. You guys should definitely have this on your bench. I hope that you guys enjoyed this video, and I will see you on the next one.